these are the solutions for homework 12-2. It says, write the first four terms in the general term of the power series for f prime centered at x equals 2 and find f prime of 2. Okay, so I think what I'm going to do is I'm going to take the derivative of this polynomial, and the derivative of 1 is 0, negative 1/3 plus 2/9, reduce the power by 1, minus 3/27, reduce the power by 1. Then on the general term, okay, taking the derivative with respect to x, and I'm going to change negative 1 to the n. I'm going to bring down this power and reduce the power of the thing with x by 1. And 3 to the n is going to stay 3 to the n when you take the derivative with respect to x. That means that f prime of 2 is going to be negative 1/3. Okay. You could also see that just by looking at the power series for f, right? Because it's f of c plus f prime of c times x minus c. Okay. So write an equation of the line tangent to the graph of f of x at the point where x equals 2. Okay. So I'm going to need a point, and I'm going to need a slope. Remember that the Taylor series is f of c plus f prime of c multiplied by x minus c double prime at c 2 factorial x minus c squared. Well, for the tangent line, all I'm going to need is the point and the slope, f of c and f prime of c. So I can go over here, and I'm going to say, well, f of 2 is clearly up here written out, it's 1. F prime of 2 is negative 1/3. So I've got a point and a slope. My tangent line is going to be y minus 1 is negative 1/3 of x minus 2. As near x equals 2, does the tangent line lie above the curve or below the curve, and justify your answer? Okay, well, above the curve and below the curve is really just like code for concave up and concave down. So I'm just going to just draw a little, a curve and a tangent line. Okay. Notice how if it was concave up, the tangent is below the curve. Okay, so I'm just going to figure out the concavity based on the second derivative, and I'm going to make that judgment. Okay, so what I need is f double prime of 2. Well, I know that f double prime of 2 divided by 2 factorial times x minus 2 squared is that x minus 2 squared term in the Taylor series. So I go over here and I grab the x squared term in the Taylor series. You can still see that. That's negative 1/9 of x minus 2 squared. Or no, positive 1/9. Okay. That means that, just not considering these x minus 2 squares, that f double prime of 2 I could solve by multiplying both sides by 2 factorial. So I'm going to say f double prime of 2 is equal to 2 factorial divided by 9, which is a positive number, meaning f is concave up at x equals 2, and if its tangent is below the curve, because the second derivative is positive. Okay. Number 2, now this is one that I probably worked in class, during the lesson. But if I want to just pull out the fourth derivative, I need the fourth power term. Okay. Because remember, the way it's going to work is it's going to be f's fourth derivative at 0 divided by 4 factorial times x to the 4. Well, this is going to be, you think, what n is going to give me an x to the 4th? And this is going to be n equals 4. So it's going to be x to the 4, where n is 4. I'm going to have 8 in the denominator. Okay. Again, I can kind of just, rid myself of these x's, because I don't really need to worry about them. And I could say that f's fourth derivative at 0 is equal to 4 factorial divided by 8. And if you know what 4 factorial is, then you could, I feel like it's 24. You could say it's 3, or you could just stop at 4 factorial divided by 8. But in a multiple choice setting, if you're just looking at a bunch of options and none of them have factorials, you need to be able to actually carry out the factorial and compute 4 factorial divided by 8. Okay. Number 3, I remember this one from last year. I know this is a good question. I'm trying to see where it's going. There's a relative minimum at x equals 2. Second degree Taylor polynomial is a plus b x minus 2 plus c times x minus 2 squared, which is about a, b, and c. Oh, I get it. Okay. So if I'm over here at x equals 2 and there's a relative minimum, it's going to be the case that f prime is equal to 0, right? Since it's a minimum, it's concave up, meaning f double prime is negative. Or no, positive. Excuse me. Yeah, smiling has positive attitude. And then, well, they're going to ask me about a. Well, a is just f of 2. Well, f of 2, if you think about it, is the y-coordinate. And the y-coordinate is going to be and the y-coordinate down here is going to be negative, right? Because I'm down here below the x-axis. Okay. So what's going to happen is that a is going to be related to f, a is going to be negative, b is going to be 0, and c is going to be positive. So that's where I'm getting answer choice A, B, C. Where is it? Oh, answer choice A. All right. All right, so the next one's a limit question. And you know, in this class, you know, if it's a limit, it's probably going to end up being L'Hopital's rule, right? So I'm looking at this, and I just need to plug in 0 and see what happens. Okay, well, based on this, I can just tell you right now that f of 0 equals 1/4. Okay. Meaning also that this limit is going to go to 0 over 0. Right? It's going to be 1/4 minus 1/4 divided by 0. That's 0 over 0. I'm going to need to use L'Hopital rule. So I'm going to take the derivative of the top, the derivative of the bottom. And then I need to find out what f prime of 0 is. Well, f prime of 0 multiplied by x divided by 1 factorial is equal to 2 over 16 multiplied by x. And so that means that f prime needs to be 2 over 16 or 1/8. And so that's where I'm going to get it's equal to 1/8 divided by 1 is 1/8. Only one iteration of L'Hopital rule necessary. That one was pretty nice. Okay, write the first 3 non-zero terms and a general term for an infinite series that represents the integral from 0 to 1 of f of x dx. Okay, well, what I'm going to do is I'm going to probably just integrate these things term by term. Right? So what I'm going to do is I'm going to say that integral from 0 to 1 of 1/4 plus 2 over 4 squared x plus 3 over 4 to the third x squared up to n plus 1 over 4 to the n plus 1 x to the n with respect to x. First step, find an antiderivative. Plus 2 over 4 squared multiplied by x to the 2, divide by 2. There's not nearly enough room on this problem to do what they're asking, but it's all right. Plus x to the third over 3 times 3 over 4 to the third. And I see where this is headed. Right? Because each time I increase the power of x by 1, and divide by the new power, well, I've got that new power sitting in the numerator, and it'll end up canceling off, right? Kind of like it did over here and over here. Well, the same thing will happen there. We found an antiderivative. We're going to evaluate it over the interval 0 to 1, and that's going to be, okay, when I plug in 1, I'm going to get 1/4 plus 1 over 4 squared plus 1 over 4 to the third, and so on, minus, and when I plug in 0, I'm just going to have a bunch of zeros. Okay. So when they ask me to find the sum of the series determined in part B, it's going to be geometric, and I'm going to use the geometric series formula. Remember, it's first term times 1 over 1 minus the common ratio. And that's 1/4 times 1 over 1 minus a fourth is 3/4, so that becomes 4/3. And that sum is equaling 1/3. Okay. If the Taylor series for 1 over 1 plus x is given by 1 minus x plus x squared minus x to the third, and so on, determine the Taylor series of log of 1 plus x. Well, think, how do I go from 1 over 1 plus x to log of 1 plus x? Well, that would probably be by, no, okay, so I'm thinking, like, where's the absolute value, right? And I'm saying it's on the interval -1 to 1. So on the interval -1 to 1, not including -1, the thing that I'm taking the log of is strictly positive, so I don't need to worry about an absolute value. So that's where I'm going to just take this thing and anti-differentiate it. Okay? So the Taylor series of log of 1 plus x is going to be the antiderivative of 1 minus x plus x squared minus x to the third, and so on, dx. Okay, so I anti-differentiate x minus 1/2 x squared plus 1/3 x to the third minus 1/4 x to the fourth, and so on, plus c. And we could probably put that c over here, right? Okay, I think this is a Maclaurin series, right? But that's a different discussion. So that's certainly enough. If you wanted to, you could find out, okay, well, when x is 0, we're taking the log of 1 is equal to 0, so c needs to equal 0. So I could actually write this as the sum, as n runs from 1 up to infinity, of -1 to the n plus 1, because it's starting out positive, x to the n divided by, I suppose, n. Okay. Number 6. Let P be the fourth degree Taylor polynomial for f around x equals 0. Write an equation for the line tangent to the graph of f at x equals 0. This is very much like that one on the front page. I'm going to say that f of 0 equals 3 and f prime of 0 is equal to negative. No, that's not true, right? Because it's the number that's attached to the x. This is going to give me information about the second derivative. Okay? So if it's missing, that must mean that the first derivative is 0. Because remember, that linear term is f's first derivative at 0 divided by 1 factorial multiplied by x. And, well, the only reason we're going to see no x is because this thing is 0, because 1 factorial is not 0. X is, we're not giving x a value. So f prime must be 0. So if we've got a point and a slope, it's going to be y minus 3 is equal to 0 times x minus 0, which is just y equals 3. Okay, f's second derivative, so f double prime of 0 divided by 2 factorial x squared is equal to negative 3x squared. I'm going to set up for the other ones. And f's fourth derivative divided by 4 factorial x to the 4 is 6x to the 4. So what I'll do is I'm going to disregard the x's, right, because they're not telling me anything I don't already know. And then I'm going to say, I'm going to just kind of solve for these things. I'm going to say f double prime of 0 is equal to 2 factorial times negative 3. and f triple prime of 0 is going to be 0 times 3 factorial, and f's fourth is going to be 6 times 4 factorial. Okay. It's a very common type of question. I know that this shows up a lot in the free response. So they're giving me information about f. G is an antiderivative for f. Find the third degree Taylor polynomial for g. Okay, we can do that. Okay, what I'm going to do is I'm going to write out the Taylor polynomial for f, and I'm going to antidifferentiate it. Okay, so f, the Taylor series for f, is going to be 3 minus 4x plus 2 over 2 factorial x squared plus 1 over 3 factorial x to the third. Okay. Okay, when I go, I'm going to get an antiderivative. So that'll be 1 over 24 t to the 4. But notice how, when I go and I plug in x, it only wants the third degree Taylor polynomial, so I'm actually going to ignore that. And I'm going to evaluate this over 0 to 1, no, 0 to x, excuse me. And when I plug in 0, everything's going to be 0, so this is going to be 3x minus 2x squared plus 1/3 x to the third. And that's the third degree Taylor polynomial for g around x equals 0. Okay. Well, the next one, if I'm going to need the coefficient of x to the third, I need the third derivative. Okay, so I'm going to say that the third derivative of h is going to be, I'm going to think of this as 1 plus 3x to the 1/2 power, 1/2 times thing to the negative 1/2, times the derivative of the inside. Let me just copy the original chain rule. Okay, so Maclaurin series is where x equals 0, so I need h triple prime at 0, and so that's going to be 1/2 multiplied by some power of 1 multiplied by 3 is 3/2. And I know that the coefficient of x to the third is f triple prime divided by 3 factorial, and that's 3/2 divided by 3 factorial. The fifth degree Taylor polynomial for f around x equals 2 is that. Is there a maximum, minimum, or neither? Okay. What we're going to do, because we're only given information at the point x equals 2, we're going to have to use the second derivative test. It's going to be a must. Okay, we can't say, oh, to the left of it, it's no. Well, that's not how it's going to work. Right? We're going to need information about the first and second derivative. Okay, so I'm going to start with the first derivative. And wait, so I want f prime of 2. Divided by 2 factorial is equal to the number attached to the x minus 2 squared. So it's going to be 1/6. Why would I do that? Okay, just ignore that. First derivative, 1 factorial, x minus 2 to the first power. I don't see a first power. That's got to be 0. Okay, yeah, excuse that. I'm doing this all in one take, so I'm not going to record over that. So that means the first derivative is 0. That makes sense, right? If there's going to be an extremum, well, I would expect the first derivative to be 0. F's second derivative at 2 divided by 2 factorial by x minus 2 squared is going to be 1/6 of x minus 2 squared. So that's 1/6, meaning f double prime of 2 is equal to 2 factorial over 6, which is positive. So if it's flat but concave up, that's looking like a relative minimum. And the reason is f prime is 0 and f double prime is positive. Is the graph of f prime concave up or concave down at the point where x equals 2, and why? Well, that's a very tricky question. If we're trying to talk about the concavity of f prime, we need to analyze the third derivative. Okay, so I need to consider f's third derivative at 2. So what I'm going to have in terms of the Taylor series is f's third derivative divided by 3 factorial times x minus 2 to the third equaling negative 4 times x minus 2 to the third. So I could say that f triple prime is going to be negative 4 multiplied by 3 factorial, which is going to be a negative number. Okay, so I would say that f prime is concave down because f triple prime is negative. Okay. Must it be the case that f has a point, or that f prime, or no, f double prime has a point of inflection at x equals 2? Why or why not? Well, that's interesting. Point of inflection could be, it's where the second derivative of this thing changes signs. So I need to see a sign change in the fourth derivative. Now, I'm not going to really be able to do before and after analysis, so what I need to do is I need to think, is the fourth derivative 0 while the fifth derivative is non-zero? Okay, well, the fourth derivative is 0 because, and you can't see it, it's off the screen, but there's no fourth power term. Okay, so f's fourth derivative at 2 is 0. F's fifth derivative at 2 is non-zero because there's this 2 here. I could solve for it. I feel like it's going to be 2 multiplied by 5 factorial, you know, based on how this and stuff recently has gone. But, you know, it's going to be non-zero. And so, yes, because the second derivative of f double prime is 0 while the third derivative is non-zero, which is, you know, an equivalent condition to demonstrate that there is a point of inflection. Okay, find the value of f's fifth derivative at x equals 2. Well, I tried to avoid it up here, and I'm going to have to do it anyway. F's fifth derivative at 2 multiplied or divided by 5 factorial times x minus 2 to the 5 is equal to 2 times x minus 2 to the 5. Meaning, I can get rid of the x minus 2 to the 5s, that f's fifth at 2 is going to be 2 times 5 factorial, which maybe 240. This is safer. Okay. Let p be the fourth degree polynomial for f around x equals 0. What is f's fourth derivative at 0? Okay, this is the exact same problem I did before. So f's fourth divided by 4 factorial times x to the 4 is equal to 2/9 of x to the 4. Ignore the x to the 4s. I'm going to say f's fourth derivative is equal to 2/9 of 4 factorial. Okay, let Pn be the nth degree Taylor polynomial for f around x equals 0, making it a Maclaurin polynomial. It's known that, okay, they're giving me, oh, this one is really interesting. They're going to give you, all right, so I want the second degree polynomial. So the second degree polynomial for f around x equals 0 is equal to f of 0 plus f prime of 0x plus f double prime of 0 divided by 2 factorial x squared. Okay. Well, I can go in, I can say f of 0 is 1/3. F prime is unknown, but f double prime is 4/3. So when I divide by 2, I'm going to have 2/3. Okay, just from plugging in that number here and this number there. And they say I get 1/8 when I plug in 1/2 for x. 1/8 is equal to 1/3 plus this thing I'm looking for multiplied by 1/2 plus 2/3 of 1/2 squared is going to be 2/3. 1/4 is 2/12. So I'm going to just kind of, in the interest of time, I'm going to say f prime of 0 is equal to 1/8 minus 1/6 minus 1/3. And then to solve for f prime of 0, I'm going to have to multiply everything by 2. And I'm just going to, there. Because otherwise I'd be looking, I think, for, a common factor, a common denominator of 24, and I'd have 3 minus 4 is negative 1, minus 8 is negative 9. I think I have negative 9 over 12. Yeah, but that's where I'm going to stop. Let P be the fourth degree Taylor polynomial for f around x equals 2. Okay, it's infinitely differentiable. Find the value of f of 2. F of 2 is just going to be that first number right here. And then I'm going to assume that's triple prime. It didn't print very well. Okay, just going on the assumption that it's triple prime. F triple prime of 2 divided by 3 factorial multiplied by x minus 2 to the third power is going to be, what is it, negative 12 of these x minus 2 to the third powers. So again, I'm going to, disregard the x's and just kind of get at the f triple prime of 2. Negative 12 multiplied by 3 factorial. Okay. And I'm realizing I did that whole thing without it on the screen. That's not ideal. But it's the same exact problem we've been doing for a while now. All right, f is sine of 2x plus cosine of 2x. Let p be the third degree Taylor polynomial. 19. Well, that's kind of annoying. I think what I'm going to do is I'm going to write down the polynomial for sine of x plus cosine of x, and then I'm going to leave room to substitute in the 2x. What I'm going to do is I'm going to start with cosine, because that's the one that starts with 1. So it's 1 minus x to the 2 over 2 factorial plus x to the 4 over 4 factorial, and so on. Then sine is positive x minus x to the 3 over 3 factorial plus x to the 5 over 5 factorial, and so on. And if I'm going to replace x with 2x, I'm just going to do that by replacing x with 2x. And this is a Taylor polynomial for f. Okay. And what's going to happen is that it's going to end up being it's going to be positive, positive, negative, negative, positive, positive, negative, negative. So pretty much what's going to happen is it's going to end up being either positive 2x taken to the 19th divided by 19 factorial, or it's going to be negative. And so what I got to figure out is, am I going to have positive, positive when I do 18, 19, or is it going to be negative, negative? So I don't really know how else to do this, but I've got 2, 3 being negative, 4, 5 being positive, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18, and 19. Okay, so it's going to be negative. I'm sure there's a better way to demonstrate that besides basically finger counting, but, if you've got a better way, let me know, and I'll tell everyone else. Okay, I think someone came up with a pretty slick way to do that last year. I just forgot. So p of x is this thing at 6th degree for f around x equals 0. What's the value of f triple prime? It looks like triple prime, and this one's great. I'm going to say, well, there's no x to the third term, so it must be that f's third derivative is equal to 0. Because there's no x to the third power term. The coefficient of x to the third in the Taylor series for e to the negative 2x around x equals 0 is what? Okay, this is good. This is one kind of like that, group quiz we just took recently, or that worksheet that's, I think it's called Classwork 4.7 from when I, indexed the course very, very differently. So what I'm going to do is I'm going to write e to the x. e to the x, remember it's the easy one, it's x to the n over n factorial. But if I want the coefficient of x to the third, I'm just going to kind of start writing some stuff out. Thanks. And so on. But if I want to do e to the negative 2x, what I'm going to do is I'm going to replace x with negative 2x. Okay. And then pretty much all I care about is the coefficient of x to the third. So I'm just going to kind of focus in on this thing right here, and I'm going to say I'm going to replace x with negative 2x. And then I want the coefficient. You could say it's negative 2 to the third power over 3 factorial, but that's not quite as fun. So I'm going to say that's negative 8 divided by 6 x to the third, which is looking like negative 4/3 to me. Okay, the fifth degree Taylor polynomial for tangent is that. Okay, well that's interesting. If f is a function such that f prime is tangent of x squared. Oh, right, so we're going to have to take it on faith that this is enough information to solve the problem. So what I'm going to do is I'm going to start by writing an equation for a polynomial for tangent of x squared. And I'm just going to replace x with x squared everywhere. Plus 1/3 of x squared to the third plus 2 over 15. 2 over 15 times x squared to the 5. Okay, well, that's x to the 2 plus 1/3 x to the 6 plus 2/15 of x to the 10. Oh, and I see it. When I go to bump up the power by 1 to take the antiderivative to get f, that's going to turn into a 7th power term. So this is going to work out. Okay. The better question would have been, well, no, there's other good questions you could ask in here, but this is already a good question. So I'm going to say that f is equal to, say the antiderivative of tangent of x squared with respect to x, which is going to be 1/3 x to the third, plus I'm going to increase the power by 1 and divide by the new power. And, I've already done the work. It's 1 over 21. I'm happy, but I'm going to just kind of finish it off. And I'm going to say it'll be 2 over 15 times 11 feels like 161. And, that's wrong. It doesn't even matter because I'm going to say the coefficient is 1 over 21. Okay, the Maclaurin series for f is given by f equals this big polynomial on its interval of convergence. Which of the following statements about f must be true? Well, okay, they're asking about max, min, point of inflection, stuff like that. Well, first of all, I can tell you right now that the second derivative is non-zero because I see an x squared term. So while second derivative 0 does not guarantee you a point of inflection, and point of inflection does not necessarily guarantee you a 0 of the second derivative, for a polynomial, those things must be true. Okay, the only place where you're going to have a point of inflection without a 0 in the derivative is if you have a discontinuity in the second derivative. And polynomials are infinitely differentiable. You can take the derivative as many times as you want, and it's always going to exist. So I'm going to just completely disregard answer choice D. Very unlikely. So max, min, or neither. What I'm going to need is I'm going to need f prime of 0. Well, f prime of 0 divided by 1 factorial multiplied by x to the 1 is equal to, well, there is no x to the 1 term. So that means to me that f prime of 0 equals 0. Then I'm going to consider the second derivative. F double prime of 0 divided by 2 factorial times x to the 2 is equal to negative 1/3 of x squared. So f double prime of 0 is going to be negative 1/3 of 2 factorial. Okay. That's a negative number, so if it's concave down while being flat, that's a relative maximum. All right, we're closing in. I think this is the last page. Yes, thankfully. Okay, the Maclaurin series for f is given by negative 2 to the n plus 1x to the n over n plus 1. Okay, seeing all of this, this is all great. Which of the following is the third degree Taylor polynomial for cosine of x times f of x around x equals 0? Here we have ourselves a situation where we're going to have to set up for, but not actually compute, like an infinite foiling situation. Okay, and oh, I see that's going to happen again right here. Okay, I should have done this in the notes in the first section I did. I'll make sure to do that in the later sections. So cosine of x is 1 minus x squared over 2 factorial plus x to the 4 over 4 factorial. Well, I'm not going to even need to worry about this term because what I'm going to do, I'm setting up for, large distribution. I'm going to use the box technique. Really is the way to go. This is higher than third degree, so I'm not even going to need to worry about this. And so what I'm going to do is I'm going to say 1/2 x negative 2/3 x squared and 1x to the third is what I'm going to need. Really only caring about these places, and I need all of the terms up to the third degree. So that's 1/2 x negative 1/4 x to the third, 1x to the third. And I think that's going to be sufficient, right? Because I know that that's going to be 4th degree. This is going to be 5th degree. We don't need to consider that. This is going to be 2nd degree. And look at this. 1x to the third minus 1/4 of x to the third is going to need to be 3/4 of x to the third. Okay. Now I'm going to carry it the rest of the way through. But I'm done. Okay, right? It's going to be 1/2 x negative 2/3 x squared plus 3/4 x to the third. Okay. And then what is the coefficient of x to the 4 in the cosine, or in the Taylor series for cosine squared x? Okay, cosine squared x is cosine of x squared, which we could say is cosine x times cosine x, which is going to be 1 minus x squared over 2 factorial plus x to the 4 over 4 factorial times itself. So I'm going to set up for and I'm only concerned with coefficient of x to the 4th. So this 1 and this negative x squared over 2, I don't really care about. Right? All I care about is x to the 4th. So 1 over 24 x to the 4. Where else would I get a 4? If I added 2 to 2, it would be right here. And so that's going to be negative times negative is positive. X to the 4 divided by 2 factorial is 2 times 2 is 4. Okay. Then this one is going to be again, an x to the 4 divided by 4 factorial is 24. So I've got 1/4 plus 2 24ths is going to be like, well, 1/4 is 6 over 24, and 2 is 8 over 24, and that's where I'm going to include answer choice D. Okay, now the last one. I've got f triple prime of 0. You should be very fluent at this by now. This has been very repetitive on this homework. I'm saying f triple prime at 0 divided by 3 factorial multiplying by x to the third is negative 1 over 4 factorial x to the third. So I'm going to conclude that f triple prime at 0 is equal to negative of 3 factorial divided by 4 factorial. F's 15th is going to require a little additional analysis. I'm going to have to figure out what is the 15th power term. What n do I even have to select? Okay, so 2n minus 1 equals 15. That's when 2n equals 16. So I need to plug in n equals 8. So when I plug in n equals 8, I get negative 1 to the 9 is negative 1, multiplied by x to the 15, divided by 2n is 16 factorial. So what I'm going to conclude is that f's 15th derivative at 0 is going to be, I'm going to multiply that across, and I'm going to say the negative of 15 factorial divided by 16 factorial. And that's all of it.